Hey everyone, this is ECE 4534 Embedded System Design. We are Group 2, Fall 2010. I'm Aaron Romano.
I'm Nathaniel Bishop.
And I'm Kevin Zeng.
And we did the SmartHome network device enumeration project that pretty much it will allow a user to identify all the devices in their home and give them control over them so you can control them remotely, say from a computer that's maybe not at your house or could be in your house. So yeah, that's what we're going to demonstrate for you guys now. As you can see here, here's our setup of the system. We've got several different components to it that we've worked on over the course of the semester. Primarily we have the Spartan 3E starter kit that serves as the central processor to the entire system. We have that connected via an Ethernet to a wireless router, which is going to be accessed by our web interface here, where the user can control all the devices. Aside from the web server user interface, everything else is transferred, all the data is transferred over I2C. So we have a PIC demo version 5 board here that buffers all the I2C data. And the first stop on the line is the Insteon PIC, which communicates with the Insteon daughter board here and runs up to a control link here, which is going to be controlling all these different devices up here that we have connected, which we have 2 lamps and a speaker subwoofer set. And on the last part on the I2C bus is the printed circuit board that we designed for our group, and that handles all the sensor input, which we have light sensors and microphones to handle the detection of different kinds of devices, such as sound outputting devices and light outputting devices.
So this here is our main web user interface for the user to interact with our system. So right here we have our basic control panel to control each individual device on the network. So we have a button to turn on and turn off each device. Then we have the status box here. Status box here just displays what the current status of the environment is. When we first power up the system, no devices are found because we have not run check yet. So it assumes that there are no devices currently connected, and therefore the type of device is also unknown. Once we click the check network button, it'll run through a polling sequence and see if there's any devices connected onto the network. For our web interface to be made possible, we needed a server to host our web interface. So right here we have the Spartan board doing that. So our Spartan board is acting as a server, and it's handling requests sent from the web interface and sending information out to the entire network. So basically our interface right here is using wireless because the server right here is connected using an Ethernet cable to a router which broadcasts the interface wirelessly. So basically any computer connected to the network can control any device on the network.
One of the components on the I2C bus, as we said earlier, is the Insteon PIC board, which is using a PIC V5, and that's connected to an Insteon daughter board, which is connected via an Ethernet cable RS-232 to one of the control link modules here on the Insteon system. And the way Insteon works, as probably most of you know, it sends signals over the AC lines on a power strip, and so we have 3 lamp link modules, which each one is connected to one device. Here is one of the lamps that's connected to this first one. There's another lamp connected to the second one here, and then we have our subwoofer speaker system set up here, which is hooked into the third link module. And just for future reference, the speaker system is hooked up to a laptop up here, which is going to be outputting a constant 1800 hertz tone
So this is the printed circuit board that we designed. Its purpose is to gather all of the sensor inputs for our system and relay them back to the Spartan board itself. It has multiple inputs for light sensors, which we can use to detect the lamps for when they turn on. It also has inputs for microphone sensors that we can use to detect sound from. It captures all these data values and sends them over I2C to the Spartan board.
Okay, so now we're going to give you a demo of our whole system working. So as of now, as we look at the status box, we see that nothing is found because we just started our whole system up. So in order to try and see if there's any devices connected to our network, we check this check network button. Once we click that,
it mimics that bit in the W. If you think about it.
So this.
the command sends through the server. Then the server turns on each device one by one, and then detects to see if any devices, if the devices successfully turn on. So as you can see, as the lights turn on, the photodiodes are grabbing the sensor data and comparing them with the ambient values. Okay, so after the check is complete, our web page reloads. Once it reloads, if we take a closer look at the status box again, we see that all the devices indeed were found. So the first two devices that we checked were light devices, and they returned back as light devices. The microphone device did return back as microphone, as the last device was a sound device. So once the polling finishes, the status is all set to off. That way, we set the state of the whole system into a state that we already know. So once polling has finished, we now have the ability to turn on a device one by one. So if we want to turn on device 1, which is a light, after we click the button, we can see that the light turns on right there. And then once that command processes, our web page reloads, and then if we take a closer look at our status, we can see that the status of our first light is on. And by looking at the device itself, we can see that the light did indeed turn on. If we decide to turn it off, we can click turn off device 1, and taking another, and then the light, as we can see, turns off. So once the web page updates again, we can see that, okay, the device did turn off.
So we designed our system to take into account a number of outside factors, such as the ambient light or sound in a room that we might not have control over, whether it come from a window or light that might not be on the Insteon network, or perhaps a noisy room full of talkative people. So I'm going to demonstrate that we can still run the device network check, and we'll still work with this added ambient light. Now the reason we can do this is before we turn on any device in the Insteon network, we take a reading from all of the sensors to get an initial value of the ambient sound and light in the room, and we take that value and compare it. We take that value and compare it to the value that we receive after we turn the light on, and if there's a significant jump in the values, we can safely tell that we have detected a light or a sound emitting object.
As an added feature to our system, we also designed an Android app that would allow the user to control the devices and do the polling sequences and everything from an Android-powered phone as opposed to the web interfaces before, so we can demonstrate that for you now. And here's the home screen for our Android app where you can initiate a polling sequence just like on the web interface. And it should turn on one light at a time and read from the sensors just like before. Also to note, we have on the Insteon pic here, each LED corresponds to one of the devices, so when the first LED is on, the first device should be on as well.
Well, then, because I mean, I could tell if it doesn't work.
does or it doesn't, but do you have a
And once the polling is complete, we can get the network status and see that the first two devices are lights and the third one is a sound emitting device. So we can control each one individually just like before. We can turn on device 1 and the lights should turn on.
Because this, I mean, like, this really doesn't help you at all, because without the stimulus file, you have no idea.
And just like before, also we should be able to turn it off
to know is that
by issuing the turn off
CRC.
device 1 button. And you can repeat those for the second and third devices as well, or you can initiate a new polling sequence again to repopulate the list.
So I think there are a few areas of improvement that we could have with the PCB board. Primarily to get rid of all of these LEDs as they're only used for debugging purposes, and we could save some power and some board real estate by removing them and the resistors attached to them. I think spacing the board out more would be helpful too, because as you can see it's kind of crowded, especially around the input area. I think replacing the voltage regulator that we broke would certainly be more power efficient, and that will come in time. I think that getting higher quality microphones would be good, as we saw the microphones tended to pick up higher frequencies well, but the lower frequencies it kind of lacked the ability to pick them up and detect them well.
So, with reliability on the Spartan side, as far as the server goes, it's not as reliable as we want it to, in the fact that it does not, it doesn't like to handle multiple requests at a single time very efficiently. Therefore, it tends to crash a lot. On the other hand, like several improvements would be probably on the server side, how it like handles messages and like how it sends them out and receives them.
Of all the components in our system, the SmartHome Insteon network worked pretty reliably, so we could usually trust that that was not breaking our system as we designed and tested it. It did a couple times though. We've noticed on the debug LEDs that a command was issued, but we could see that it wasn't being carried out by the Insteon system, but those were relatively few and far between, so that was good. Currently we are using 3 lamp links for the different devices, which, from our understanding, when you turn on one of the lamp links, it slowly releases voltage to it to dim the device on slowly, as opposed to just turning it all on at once. And for that reason, when we were demonstrating the subwoofer sound system using one of those lamp links, that's probably why it kind of would flicker on and off a bit. And also, from my understanding, there's something called an appliance link, which provides the voltage directly and quickly, such that we wouldn't have to deal with the flaky turning on and turning off of the sound system.